line integral over a path which was rectangular in the xy plane, and we said that, let me write this like this, E dot dl over this path, although it's a very small path, let me write this as an integral, was equal to curl of E dot ds, where ds represents this small area. So this becomes the definition of curl. It is very clear, if there is a vector field that is going around like this, if I take this path, this integral is not going to be 0. On the other hand, let us look at a vector field which is constant all over, and let me take this path here. You will notice that E dot dl over this will give me one value which will be exactly opposite of its value over this path. So going this way, I'll get one value which is exactly opposite of something going this way. Dot product over this path is 0, but the net result is that E dot dl in this case is 0. And this implies that curl of this vector field is 0, or at least the z component is 0. So very interestingly, you notice that when something swirls around or curls around, right, it has a curl which is non-zero. Something which is constant has a 0 curl. Let's take another example. In the xy plane again, if I have a vector field which is increasing with distance, and if I take a path like this and this, and again calculate E dot dl, you will notice that on this side, let's name it 1, 2, 3, 4. Contribution on 2 would be larger than the negative contribution on 1, or on 4, sorry. Why? Because as you're going towards the right, the field value is increasing. On the other hand, on 1 and 3 it is 0. So E dot dl on 2 is greater in magnitude than E dot dl on 4, and E dot dl on 1 is equal to E dot dl on 3, which is 0. So again you notice that if I do E dot dl over the entire path, which I'll write as the line integral E dot dl, is going to be non-zero. But that makes sense, because now you see this field gives you an impression as if it's going to turn around. It is only when something turns around that as you go away from the center that the speed or the vector increases. All these concepts actually came from fluid dynamics, and therefore a physical field for curl will arise by the following arguments. Imagine that this vector field that we are talking about is representing the velocity of a fluid flow, and put a small stick in it, maybe a toothpick, maybe a matchstick. If this tends to turn, right, so let me make it by different color. If I put a small stick and if it tends to turn, then curl is non-zero. If it does not turn, then curl is 0. And sense of its turning will also give you the direction of the curl. Right? Again, move your fingers in the direction in which it tends to turn, then the thumb gives you the direction of the curl. That is the physical feeling of this. It is also related to, so curl can also be related to work done in going over a closed path. How so? Let's see that. Again, go back to xy plane. I'll generalize it to 3D in a minute. Take a charge q and take it around. Now E q dot dl summed over which I am writing as q integration E dot dl, is nothing but force on the charge dot dl. So this integral represents work done in taking charge q over a closed path. So this we understand E dot dl is work done in taking a unit charge. Let's write q equals 1 around a closed path, and this is related to curl dot delta S. Therefore, if work done is non-zero in going around a closed path, the curl is non-zero. If work done is 0, then curl is 0. Let us see what happens for an electric field. If I have an electric field, and if I go from this point to this point, all right, and this point to this point, right, work done may be the same, and we will see that in a minute what it means. All right. So let us calculate curl for E field. If I were to calculate curl for E field, remember E for a unit charge at r, charge at r prime, I have written it earlier, so I will just write it directly, is q over 4 pi epsilon 0 r minus r prime over r minus r prime cubed. So Ex is that constant q over 4 pi epsilon 0 x minus x prime over x minus x prime square plus y minus y prime square plus z minus z prime square raised to 3 by 2. Ey is q over 4 pi epsilon 0 y minus y prime over x minus x prime square plus y minus y prime square plus z minus z prime square raised to 3 by 2. Let us calculate their derivatives. So partial Ex over partial y is going to be q over 4 pi epsilon 0 x minus x prime over x minus x prime square plus y minus y prime square plus z minus z prime square raised to 5 by 2, and here I am going to have a y minus y prime times 3 with a minus sign. Similarly, E y over E partial x is going to be minus q over 4 pi epsilon 0 3 y minus y prime x minus x prime over this whole thing raised to 5 by 2. So curl of E, z component, comes out to be 0. All right. Similarly, you can see that curl of E x component is also 0, and so is the y component. You can check that just like I did for other components. That means in general, for a point charge q, curl of E is 0. Now, if I have many charges or charge distribution, E is nothing but summation of different E's, or rho r prime over r minus r prime cubed r minus r prime dv prime 1 over 4 pi epsilon 0. When I take curl, which is derivative with respect to x, y, and z, it's going to act only on this part of the integral, and in this case it gives 0 for individual fields. So overall you can then see that curl of E comes out to be 0. That means if I go around any small closed path, net work done is going to be 0. How about a larger path? For a larger path, recall the trick we did for divergence. Similarly here, if I take a large path, I can divide this into many small rectangles. Let's look at two adjacent rectangles and traverse them counterclockwise. If I do this, you see the E dot dl over this encircled path, which is traversed twice, once this way, is going to give me 0 when I add it up. So all the adjacent paths are going to give me 0 contribution to the line integral, with the result finally I'll have only line integral left, which is outside line integral, because these are not adjacent to any other rectangle. So summation E dot dl over small rectangles, and then this summed over all rectangles gives me integral E dot dl, where dl is only the outside path. But this is by definition equal to summation over each rectangle curl of E dot delta A, and then I am summing over all rectangles. So this gives me nothing but the surface integral curl of E dot ds over the entire surface. So what we learned from this is that given a surface, curl of E over this entire surface, where the direction of the surface is again given by right hand rule, is going to be nothing but E dot dl on the outside path, and this is known as Stokes' theorem. So now we are ready to understand the physical meaning of this curl. See, earlier I have given it to you, it gives you a sense of if an electric field is turning around, but with this, when we saw that E is 0 for an electric field, that means any path I go around, work done is going to be 0 in taking the charge around. Let us take 2 points on this path. Let us traverse this path once like this and once like this, okay, from point A to point B. The work done is going to be E q dot dl from A to B. Let's call this path 1, let's call it path 2, along path 1, and q E dot dl A to B along path 2, and I am going from A to B. But notice that A to B along path 2 is same as minus of path B to A dl along path 2. Now integration A to B E dot dl path 1 plus B to A E dot dl path 2 like this, and then path 2 I am going like this, is 0 because curl of E is 0. What is this? This is minus from these two equations from A to B, and this implies a to b E dot dl path 1 is equal to integration a to b E dot dl path 2. Notice that path 1 and path 2 are arbitrary, and therefore, what we conclude from this is that if curl is 0, work done is independent of path and depends only on the endpoints. This is the definition of conservative field. That means work done can be written as W1 minus W2 or W2 minus W1, and later we are going to identify these as the potential energy. So for a conservative field, we can identify potential energy because I can define at each point that between 2 points what will be the work done, because independent of the path, and therefore curl of E being 0 implies E is conservative. Line integral over a path